Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look at how do we find values that correspond to particular areas on the normal distribution. So let's say we know the area under a particular normal curve, then we have a method for working backwards to find the z-score or the x value that corresponds to that area. So let's take a look at on a standard normal distribution, that is a normal distribution with a mean of 0 and a standard deviation of 1. What we're going to start by doing each time is we're going to draw a picture that represents that. So here I've got just a picture of my standard normal distribution. So let's say that we are interested in finding out the z-score that corresponds to 60% of the area below that. Then what I want us to do is I want us to shade what that would look like. So I know that half the area is below the mean. So I'm just going to kind of guesstimate and say, well, 60% maybe would be about there. And I could kind of shade that in and give myself an idea that, okay, I'm probably looking for a z-score between 0 and 1. So drawing a picture is going to be super important. Once we've got a picture, then we need to reference either technology or a z-score table to help us out. So let's take a look at that. So in this case, let's do an example where we use the table. So find the z-score that has 59.1% of the distribution's area to its left. Now, to its left is going to be very important to us. Remember that that is what our z-score table tells us. Area to the left. Okay, so if we're already looking for area to the left, then we can recognize that 59.1% is a decimal of 5910. So we're going to kind of scan into all these decimals and try to find either exactly 0.5910 or as close as we can come to that value. All right, so I see 0.590 exactly is right here in my table. So I'm going to go ahead and grab the corresponding z-score by taking the 10th digit from what row it's in and the 100th digit from what column it's in. So my z-score that corresponds with an area to the left of 0.591 is 0.23. So 0.23, that is the z-score that goes with that area. Let's take a look at another example. Assume that the heights of college women are normally distributed, with mean of 65 inches and standard deviation of 2.5 inches. It is said that women in the highest 20% have a hard time finding jeans that are long enough for them. How tall would a woman in the tallest 20% of college women be? So here, let's take a second to draw ourselves a picture of what that might look like. So if we have our normal distribution here, if we're talking about the tallest 20%, well, I know that the mean always sits at 50%, and I know that as I go to the left, that would be getting shorter, and as I go to the right, that would be getting taller. So let's say tallest 20% would look something like that. So if we're going to be using our z-score table, remember that this only has area to the left in it. So knowing from our properties of normal distributions that the entire area under the curve has to add up to 1, if there is an area of 0.2 to the left of my particular value, then I know that the area to the right would be 1 minus 0.2 or 0.8. So in my z-score table, I'm going to be looking for a value of 0.8. Now I notice that I can't find exactly 0.8. So I look for a value as close as I can get to that. So I see that 0.8 is probably around this area, somewhere between a z-score of 0.84 and 0.85. So I'm going to go ahead and just estimate using one of those and say that my z-score would be 0.84. Now, a z-score is on a standard normal distribution, but we are on a distribution with a mean of 65 and a standard deviation of 2.5. So remembering our z-score formula is x minus the mean of mu divided by your standard deviation sigma, we can fill those values in and solve for x. So our mean is 65 and our standard deviation is 2.5. We're interested in what this x value is, so we'll go ahead and take some steps here to solve for x. So the first thing I would do is multiply both sides by 2.5. So 2.5 times 0.84 is 2.1. So now I have 2.1 equals x minus 65. Going ahead and adding 65 to both sides, I get an x value of 65 plus 2.1, or 67.1 inches. So here we're seeing that the top 20% of women will have heights greater than 67.1 inches. All right, guys, that does it for this video on finding values on a normal distribution using a table. Check back with us in the future for more videos.